Alright, so we've been looking at the past couple days, analyzing or evaluating limits graphically and numerically, meaning we plugged in the numbers numerically, and graphically means we looked at the graph to figure out the limit. But now what we want to do is we want to start to find the limits algebraically. There's a method that we're going to use, an overall strategy, and the first thing we're going to do is we're going to use direct substitution. If we end up just getting a plain old number, no problems occur. That's the answer. However, if we get a 0 on the bottom of a fraction or a 0 where something's undefined, we're going to simplify and then we'll try that number again using direct substitution. So the last thing we'll do is if the division by 0 occurs and the function is completely simplified, then we'll have to compare the limit from the left and from the right to see if they're equal. And if they're not, then we'll know the limit does not exist. So let's go ahead and get started, and we're going to start to look at some of these examples. And like I said, we're not going to be drawing graphs. We could be looking at a graph every single time, but what we're going to use is this algebraic strategy. So on this first problem, it says find the limit as x approaches 1 of the function 3x minus 1. Well, first thing we always try is direct substitution, so I'll plug that in. Direct substitution will give me 3 minus 1, so my limit is 2. On number 2, we'll try direct substitution first to see if it works. And on this one, we get negative 4 plus 3 to the 1,984th power. Well, that gives me negative 1 to the 1,984th power. Since that's an even power, I know my answer is 1. On number 3, if I try direct substitution, I get 5 minus 5 on the bottom, which is 0. So I need to simplify first. Well, the method for simplifying for this one would be just to factor. So I'm going to factor the top into x minus 5, x plus 5. That allows me to cancel on the bottom. And now I'll try direct substitution again. So I'll take and plug in my 5 plus 5, and so my answer is 10. The limit as x approaches 5 is 10. Number 4, if I try direct substitution, I'm plugging zeros in, and I get 0 over 0, so that's not going to work out. I need to simplify. I'm going to look at factoring again. Factoring on the top, I could take out a greatest common factor of x squared, and I'd be left with 5x plus 8. On the bottom, I could take out an x squared, and I'd be left with 3x squared minus 16. I haven't taken the limit yet, so I'm going to recopy that part. I can cancel my x squareds, and then I can use direct substitution again to come up with my answer. 5 times 0 plus 8 over 3 times 0 squared minus 16. So I end up getting 8 over negative 16, which reduces to be negative 1/2. Continuing on, I have some more limits here we're going to look at in different manners. This first one, if I try direct substitution, which I'm always going to try first, I get 5 cubed minus 8 over 5 squared minus 4. And I end up getting 125 minus 8 over 21. And then I could say the answer is 117 over 21. So direct substitution worked on that one. On my next one, when I plug in 4s, try direct substitution first. I get 16 minus 20 plus 4, so that's going to give me a 0 on the bottom of the fraction. So I'll look at the limit as x approaches 0, x minus 4 over, factor the bottom, x minus 4 times x minus 1. The x minus 4's cancel, and now I can use direct substitution again. So I'd have 1 on the top and 4 minus 1 on the bottom, which would give me an answer of 1/3. On number 7, where we left off from the last video, if I plug in 2, I can see I'm going to get 0 on the bottom of the fraction. So I'm going to simplify this by factoring the top. Canceling and plugging those back in. 2 minus 5. 2 minus 5 is negative 3. Last problem on this slide, I have a difference of cubes. If you haven't remembered how to factor a difference of cubes lately, this might be something that you need to address during classes, how to factor a difference of cubes and a sum of cubes. You should know how to do that. A difference of cubes is factored into x minus a, and it's x squared plus ax plus a squared over, I have x squared minus a squared, and then x squared plus a squared. But this is another difference of squares, so I'm going to just go ahead and erase this right here and put in x minus a, x plus a. Now looking at it, I can cancel. And on top, when I plug in a, I get a squared plus a times a plus a squared over a plus a times a squared plus a squared. So on the top I end up with a 3a squared, and on the bottom I have a 2a times a 2a squared, which gives me a 4a cubed. And then I can simplify that just a little bit by reducing and getting 3 over 4a. This next problem is asking me to find the limit of g of x as x approaches 4. So we'll go ahead and just try the direct substitution. When I do that, I get 12 times the square root of 4 minus 3 over 4 minus 9. I'm not getting 0 on the bottom of the fraction, so I'm going to continue on. I've got 12 times 2 minus 3 all over negative 5. And then that gives me a negative 12 over negative 5. So I end up with a positive 12 fifths. And the second one here on part B, I'm going to plug in 0. So I have 12 times the square root of 0 minus 3 over 0 minus 9. This gives me 12 times negative 3 over negative 9. And I end up getting a negative 36 over negative 9, which is equal to a positive 4. And my next problems here is asking me to find the limit as x approaches 1 of f of x. So that's simply done by plugging that in. I get 1 plus 7, which is 8. Part B, plug in 4 into my g of x. So I get 4 squared, which is 16. And the last one says the composite function. So I'm going to go ahead and figure out what the composite function is first. So I have g of f of x. F of x is x plus 7, so I'll write x plus 7 here. And then I'll have the limit as x approaches negative 3 of g of x plus 7. So I'm going to plug that in for my x value, and I have x plus 7 squared. Now I can go ahead and use direct substitution, and I get negative 3 plus 7 squared. Well, that would be 4 squared, which is 16. Some other examples, these are all trig functions, and what we're going to do is just try direct substitution. We're going to see if it works. The tangent of pi. Well, the tangent of pi is sine of pi over cosine of pi. The sine of pi is 0 and the cosine of pi is 1, so my answer is 0. Next one, plug in 2. It says the sine of 2 pi over 2. Well, those cancel. The sine of pi is 0. The next one, I have cosine of 3 pi. The cosine of 3 pi on the unit circle would be all the way back here, so it would be -1. This next one would be the cosine of 5 pi over 3. This is a reference angle of 60 degrees. Let's see here. 5 pi over 3 would be somewhere in the fourth quadrant here. Reference angle of 60 degrees. So I would be saying the cosine of 60, which would be 1/2. But since it's in all students take calculus, the fourth quadrant is positive for cosine, so it is 1/2. And the last one here on this slide is secant of 7 pi over 6. That's the same thing as 1 over the cosine of 7 pi over 6. This time I have a reference angle of 30 degrees, which would be 210 degrees here. So that would be in quadrant 3. So my answer is going to be negative because cosine is negative in that quadrant. This is all stuff from pre-calc. If you don't remember this is things that we can discuss during class. It'd be square root of 3 over 2. And when you divide by the reciprocal, we'd end up getting -2 over square root of 3. I have 2 more slides and I'm going to quick finish up, and those are properties of limits, and then we'll do just a couple problems with those properties. This is all in your textbook as well, but you need to realize that there are properties of limits, and those are the scalar multiple. What that means is something's multiplied by that function. The limit is equal to whatever that limit is times that multiple. So you can pull that multiple out front. There's a sum or difference, meaning that if you're finding the limit of 2 functions being added together, you could actually find the limit of each one separately and then just add them or subtract them. The same thing for the product. You could find the limit of each of the functions separately and then multiply them together. Quotient, you can take the limit of each part and then just divide them, but realize that the bottom can't be 0. And the last one is the power property, and the power property just says that you could find the limit of f of x and then raise it to that power. So we're going to use those in order to figure out these limits right here. So they say this is the scalar multiple one, so you're multiplying it times f of x. So they tell us what the limit is equal to, so we're just going to say the answer is 4 times 3 over 2, and so my answer is 6. Number 2, they're telling me that I'm adding 2 functions together. Well, so I'll take the limit of each one of them separately. 3/2 is the limit of f of x, and I'll add it to the limit as x approaches c of g of x, which is 1/2. So my answer ends up being 2. The next one, I'll take the limits separately and then multiply them together. So I get 3/2 times 1/2, which gives me 3/4. And then the last part here is the division one, where I could take each one separately. I get 3/2 divided by 1/2. Well, 3/2 divided by 1/2 is flipping the fraction, so I end up with the answer of 3.